Okay, so let's go ahead and continue on with today's class. It's going to be the same concept that we have done before, which is on data protection. Okay? All right. So let's revisit some of the strategies that we had talked about here, primarily resilience. So if you remember, I said that resilience is a part of cybersecurity, which in essence translates to how do you keep your business running? How do you keep your operations continuing moving forward if there is an incident? So when I say an incident, it can be like a crisis, maybe it's an earthquake, maybe it's electricity outage. Maybe it's some form of cybersecurity attack or even a system failure. All these things are incidences or crises that would require you to implement any of your resilience plans. Now, in cybersecurity, there are significant things that can happen at any point in time. And so you need to create a resilience program, meaning you need to have plans in place in order to bounce back if an incident were to occur. Resilience is all centered around making sure that you can keep your business running as usual. Now, keep in mind, it's not trying to avoid the failure. It's not trying to avoid it because, like I said, it's not if you get hacked, it's when. It's not if a bad thing happened, it's when. So you're not trying to avoid it. You're trying to make sure you set all of these things in place, the steps in place to be able to bounce back quickly. That's the entire point of resilience. Now, resilience has a close tie to recovery because recovery, in short, is just restoring your systems and your data. So, making any of your systems, programs, software that you use back to being available after an incident. Okay. So, if there's a power outage, you want to make sure that you recover it quickly so that the availability stays low. Now, when we talk about resilience and recovery, you can imagine that a lot of companies care a lot about this, right? Well, then you might be saying, okay, well, how do I explain why? If you're explaining this to one of your family members and said, hey, we learned about resilience and recovery today, well, then you can say, well, if a company isn't able to access their software, if they aren't able to access their data, well, then one of the first things that'll be impacted is the company's bottom line. The company's bottom line, in simple terms, is losing money. If you lose money, then you could be facing a lot of damage to your reputation. So losing trust would be one where you lose trust from your stakeholders, maybe your board of directors. You could lose trust with your customers if your business is around giving your customers access to a certain tool. The one that we referenced before in our last class was if people were to lose access to Gmail or Google Maps. I, for one, use Google Maps all the time. So if Google Map goes down, that affects me personally. And then I look at the brand and say, hey, should I be looking at Naver Map moving forward? Right. Not only is this important to save money, as well as make sure to keep the trust of your customers and stakeholders, but you can also be legally liable. This is especially important when it comes to data, because if someone's data, if your data becomes leaked and the company has shown that they have not had the right privacy controls, the right data protection controls in place, well, then they could be legally liable to pay out to you, or they could pay a fine to the government or to a compliance entity. Okay? The entire idea with resilience and recovery here is that good resilience means that there's less disruption to the external world. Resilience is often not seen or appreciated as much. I guarantee you that there have been times where there's been an outage for Google Maps, Facebook, Instagram, but you didn't notice. You didn't notice because the teams at Instagram and Google, they all had a really strong resilience program. So that didn't impact you. You didn't experience an unavailability of a platform. And that's some of the things we're going to talk about today. So we'll talk a little bit more about some resilience, and then we're going to jump through some of these cybersecurity incidences. And then we'll talk about some methodologies and framework. One of the things we are going to discuss is incident response plans. We had touched on this in the past, but in this course, we're actually going to dig into it a lot more, meaning that we're going to make sure to better understand what what each important phase of the incident response plan is. And something that I really want you all to hear is socializing that. The term socializing in business terms here just means sending it out and making sure it's understood. That's a big piece. When you make these plans, when you make these procedures, well, then that's half the battle. The other half of the battle is making sure the company buys into it and that employees know about it so they know what to do. That's one of the most important pieces of cybersecurity right there. Then we'll talk about some redundancy, backups. We'll talk about RAID 0 through. I sent you all some information about that as well as some videos. And then we'll talk about some assessment and training. Okay. Now, keep in mind, when we're talking about resilience and recovery, the entire concept here is centered around layered security, layered defenses. That means that just like we have the OSI model with the 7 layers, well, then each of those layers has their own protective mechanism, but we can go a step further and have other security tools, whether that be outsourcing it or whether that be having multiple load balancers, multiple web servers, so that you don't have a single point of failure. Let me check the chat real quick. Okay. Yeah, so that image that Mustafa put up, that your mail is temporarily unavailable, that is an exact example of something being unavailable. Okay, so resilience would prevent that from happening. All right, so let's talk about building a good resilience and recovery strategy. So if you remember, we talked about security architecture, right? So the security architecture, like we talked about design before, it's the blueprint. It is a blueprint or a design that is meant to visually show you the setup of your security systems. So it's meant to show you all of your devices, your firewalls, your backups, your access control. All of these are different pieces that go onto your architecture. Now, the entire goal here with resilience and recovery is centered around the A in the CIA triad. So my first question is, what is the A in the CIA triad? Please respond in the chat. I'll be posting a lot more of these to keep everyone engaged as a way to make sure to reinforce these. Every time I ask these questions, it's because it is something that you will have to memorize. And you are correct, it is availability. Now, CIA is the confidentiality, integrity, and availability. In the availability sector, that is everything that resilience and recovery is hinging on. It's making sure that we have high availability, not just for the internal organization, but for anyone who uses the tool. This is why it's important for you as a cybersecurity professional to be aware of different industries and where they fit in. For Salesforce, they sell a product. They sell a product that is a CRM where they can store contact information, they can store automated emails and whatnot. So low availability is if that platform goes down. Okay, that's an example. Same thing with Google is they sell to their customers. Maybe another one is Amazon. They sell cloud as a service, infrastructure as a service. So that means that their website, aws.com, has to be available at all times. These are different, different ways that different industries perform and how they stay afloat, right? So when it comes to high availability, there are certain things that you can do or certain strategies to here minimize downtime. When we're trying to minimize downtime, that means including certain devices, including certain softwares to help minimize that. So what you could do is you could use a load balancer. As an example, a load balancer is a device that routes and evens out traffic based on incoming traffic. An example of a good use of a load balancer is if your company has a really big marketing event where they're releasing a new product and they anticipate a huge influx of traffic on your website. A load balancer will help even out that traffic so it goes into different servers accordingly so it doesn't all just rush in one. Then there's a concept of clustering, which is putting a bunch of servers together. We'll talk about that, don't worry, as well as having different platforms and different sites. So let's kind of dig through a little bit. Now, one of the first things we want to talk about is load balancing. Like I said, it's distributing traffic based off of a certain requirement. The entire goal of a load balancer is exactly that. Load and balance the load of traffic that's coming through, making sure that it goes into the correct server so that one of them does not get overloaded. This is one of the easiest ways to prevent your system from experiencing a major unavailability due to a DDoS attack. The load balancer can load it accordingly and, if needed, route it completely to a different location. Then there's a concept of clustering. In very simple terms, clustering is the process of connecting different servers, which in this case is called nodes, so they work like one single system. Now, if you think of one specific system, or let's say an application, right? Well, then the application, excuse me, the application, you typically think of one physical server, one physical device, and that physical device acts as the main server to give a specific service, right? So let's say, for example, we're talking about Salesforce. Now, if you put on your networking hat, you know that, okay, Salesforce, they are an application, which means that they're a software. If they're a software, they have to have a data center. They have to have a web server interface. They have to have an operations interface, and they have to have like an email service interface, because email is also one of the services that Salesforce provides. Now, all of those could be one giant system or one giant server, but more often than not, it is a cluster. It is a cluster of all those different servers that function together and that serve as one single system, right? So the idea here is that each of those servers owns their own task, right? Same thing can be done for if you're trying to protect the system from low availability. That means each of those servers, they can be clustered to improve availability and reliability. That way, if one of those goes down, well, then it can fail over to another system. I've seen clusters to where they had 3 copies of each server or each service, so that if one of them fail, there is a massive amount of redundancy. How do organizations determine the right balance between performance optimization and security robustness? That is a great question, Richard. And to be very honest with you, this is probably one of the most difficult conversations you'll have with senior leadership. Because keep in mind, senior leadership cares about removing any roadblocks that prevent their employees from doing their job. Cybersecurity is only a small part of their job. Someone who's in marketing was hired to do marketing. They weren't hired to pay strict attention to cybersecurity. So the answer to that is it depends on that organization's risk appetite. Risk appetite means how open are they to risk and how willing are they to experience risk, right? So with that concept in mind, it'll give different answers. There are some companies I know who have a really high risk appetite where they say, we don't need to do security awareness training once a quarter. We can just do it once a year and it suffices. Or you could have a company that says, oh, we don't need redundancy on these. We just need to have one backup in one location connected to our server, and that's it. Reason why? When you have as much redundancy or a lot of um, security robustness, it costs money and it costs resources to maintain, it costs space to maintain. So it is a functional friction and quote unquote potential disruptor. The other piece of it is when it comes to performance optimization, we're talking about 2 things: performance of the network and how your service is being provided, which is like the speed at which yahoo.com pops up on your screen, and the performance of your employees. If your employees are spending 20 hours a week trying to monitor and make sure that they're being secure, but only 20 hours a week doing their job, when you actually look at the numbers, well, then they aren't being as efficient and productive. So the short answer is risk appetite, and it depends. Very good question, Richard. This is something that I've personally struggled with companies where I approach them and say, hey, these are the areas where we could very much improve, but they say we only want to focus on these two because they're the ones that are least disruptive to the business. Very good question. So, when it comes to load balancing and clustering, right? Load to kind of put this into perspective. So load balancing is meant to enhance performance, right? And not just have one single point of failure. So like that bottleneck. And clustering is what we call fault tolerance, where we try to make sure that there are different features, different servers that can take on the load. And then if one of them were to fail, we can then fail over to the next one. We'll talk about failovers later on. And then implementation. Well, in very simple terms, load balancers are a lot easier to maintain, manage, and set in place. Typically, if you're using a physical one, it's just routing all of your traffic that's coming in through one device, set it accordingly, and then monitoring it is pretty easy. Now, when you cluster, because you're using a bunch of different servers and a bunch of different services, obviously it's going to be a bit more complex because you have to configure it so that if one server goes down, well, then it automatically routes to another, so on and so forth. Okay. Excuse me. So when it comes to site considerations and geographic dispersion, we're talking about disaster recovery. As a reminder, disaster recovery is there is a disaster, let's say for this case, a fire, and we need to make sure that we're able to bounce back quickly. Well, one of the two things you have to consider is the site in which it happens, as well as geographic dispersion. So the site, in very simple terms, is the physical location of your servers or of your location, so of your business. So that would be like your office or your like just a work building of some sort, right? Now, there are such things as different sites that you can back up to. So they're broken down into three different ones. There's a hot site. So think of this as if you ever watch those movies where there's a spy and he's like, hey, we have to go underground. We have to go to our safe house. If you go to that safe house is fully equipped with computers, electricity, all the secret agent guns and information, even personnel that are already working there. That's called a hot site where you can transfer everything from one location to another. Another one is a cold site, right? So the cold site, or let me pivot. There's also something called a warm site. So you have a hot site where all the computers are ready, all the equipment is ready. That's where you go. But then there's also something called a warm site. It goes from hot to warm. The warm is like, yes, there might be some computers there. There might be some of the secret agent guns there, but it's not fully operational, as in there's not someone fully available to like work it on. But you probably have to flip a couple switches, turn on electricity, and then it's good to go. And the last one is a cold site. A cold site means that there's infrastructure. Let's say it's like your computers are there and some of your stuff is there, but nothing is plugged in. So you have to manually go in and turn everything on. Mm. Thank you so much for what you said, Tekla Mariam. That really means a lot. I appreciate it. Thank you, thank you. That's very kind of you. All right, so those are the three different sites to consider. There's a hot site, warm site, and a cold site. Then when there's also geographic dispersion. So what that means is not having one sole location, but having multiple locations potentially that are gapped. That's why sometimes you'll see some organizations have multiple buildings. For example, there was one company I worked for in San Diego called Intuit, and they have four buildings. Each building is a building in and of itself. That's an example of geographical dispersion. So if one building were to have a disaster, or if one of those were to have an issue, well, then it can't easily stretch to the next building because there are security measures in place. Wow, so many people are liking that comment. Thank you so much, everyone. That's very, very kind. Um, so you want to make sure to lessen the likelihood of that spreading. Then there is platform diversity. So as you'll hear here, there's a common theme of not wanting to make sure, not wanting a single point of failure. So you don't want to put in like the American term, you don't want to put all of your eggs in one basket. You want to make sure to spread it out so you have, just like you want multiple forms of income, you have multiple forms of multiple diversity in platform. Okay. So the complexity here is that if you have too many platforms and too many softwares that you're depending on, well, then it might be, how do I say it? It might be overzealous to have that much. It might become overly complex. So you have to hit that balance of multiple systems versus one. And then multi-cloud systems, in very simple term, multi-cloud system is just saying that you have multiple different providers. It is not abnormal for a company not just have Amazon. Instead, they have Amazon, some parts in Azure, some parts in Google Cloud. For example, if you are an organization, which I've definitely seen, they have Amazon as their infrastructure cloud provider. So that's where they build their web servers, their data servers. That's where they build all that, right? But then if they have an application that they're trying to work with, well, then they're typically going to use Google Cloud, right? So Google Cloud has the Kubernetes or Docker or one of those services to actually host the application itself, right? But when it comes to IAM, which stands for Identity and Access Management, which means are you who you say you are? It's authentication, authorization, and accounting. The IAM function will be held by Azure, which is Microsoft. That's an example of using multiple cloud systems so that one of them has a specific service. So as a recap, this means Amazon is used for infrastructure. Google Cloud is used for application and containerization, which means where you're building applications. And the last one, Azure, is typically used for access control. That means you put people in certain groups, and then that Azure system is where all of the username and passwords go to check if they say who they are, if to double check that they are who they say they are, and then back. Okay? And then continuous operation capacity planning. All that means is that it's trying to make sure that we continue to look at our resilience program and where things can improve. And B, we start with the end in mind, meaning that we don't build for the now, we build for the future. So whenever you do build your own infrastructure, even if it's at home, you should build it with the concept of we're going to expand. We're going to get more computers. We're going to get more workers. We're going to get more people. So we need to build it so that it can scale. Remember, scale means building so that it can grow over time. Both of these, were in regards to operational resilience and capacity planning, involve regular monitoring and regular testing to making sure that we can identify all the areas that we can improve and identify areas that are already pretty good. All right. Let us move forward then. So now let's talk about effective testing. So when we're talking about effective testing, right, this is in specifics to backups, right? When it comes to backups, it's really important that we do things called failover testings. Now, failover testing, I'm jumping the gun a little bit here. Failover testing is essentially where you do a switch from your primary backup system to ensure that it works to your secondary backup system. So the failover testing process, it's to make sure that the failover process is reliable and that it's effective. So this is very common when it comes to web server failover testing, because then you want to make sure that if one of your let's say one of your developers makes a release. That release breaks the entire web server. Well, then it needs to be easily able to fail over. The good reason why failovers exist is because employees will have gone through a failover test, and then they know the steps on what to do to move everything over. So that's a very important exercise. The reason why it's important is because the backup is completely useless if you can't use it, right? If you are unable to route all traffic or to move all your systems to that backup, well, then it cannot be used. And the other reason why you want to do it is you want to do the testing before it's done, before you actually need it. So Peter asks, would failover testing be done off hours? So the answer to that is typically yes. You want to do it when there's the least amount of users. However, sometimes you're an organization that is going to be running 24/7. What does that mean? Take, let's say like let take like um one that's used all everywhere, google.com. So the website google.com, right? So google.com is used all over the world and everyone in the world can use Google, right? So that means there's not really a downtime. If Google wants that search engine to still function, they still have to make it work. That's why there are some failovers that do happen during live sessions. Now, typically this would be contained in like a QA environment, and there's a lot of prep work being done. But this is one of the most technical things that you would do in GRC, governance, risk, and compliance. So it is a very technical process where all engineers are involved, our IT is involved, and it's a very technical process. Now, something that's quote unquote less technical, but more a knowledge and awareness based is actually tabletop exercises. I talked about this in the past, but in very simple terms, a tabletop exercise is just a process where you put everyone in a room, like all of the leaders or anyone who would do this, and then you present them a scenario. This is a disaster scenario where you say, hey, a fire just happened in the engine room, and you ask them, what do you do? So it is to assess the awareness of all the employees on what to do, as well as the effectiveness of the plan that you put in place. Now, the tabletop exercise is very similar to the simulation because you're both presenting a scenario and then you have the people react to the scenario or tell them what they do. Both functions here of the tabletop exercise and the scenario are meant to run through the exercise and find any gaps that could be improved. The big difference here is that the tabletop exercise, you're just talking. You say, okay, I call this team, we open this Slack channel, and then we take these steps. It's just the talking process. An actual simulation would be where you actually take the steps to move the system to the backup, or you do it in like a simulated production environment. A production environment, as a reminder, is the area where live data is coming through. People are actually using your platform, right? A simulated live production environment would be like a sandbox. Now, if you're unfamiliar with these terms, a sandbox is essentially an area that mimics your production environment, but where you can test things and you can try to make things not try to break things or what have you. It's a safe environment to break it. If you were to break things in live production, that's where you have an incident. All right. So you have to have backups, right? So if you want to have effective backups, you have to consider, okay, what are the things I need to do? Well, one of the first things you need to keep in mind is if you're going to have on-site or off-site storage. Now, as we'll talk about this a little more later, so I'll skip that. But you also have to decide on the frequency. Now, the frequency to me is pretty simple. If you are adhering to a specific security standard or compliance standard, well, then they will dictate and say, you need to back this up every day, every hour, what have you, especially when it comes to critical data. SOX, SOX, the Sarbanes-Oxley Act, does have strict rules on how frequently you have to back up your data. And this is a simple area that you and your team can decide on if you have compliance if you have a compliance standard you're trying to adhere to. The next one is encryption. We talked about that in the past. It's just making everything on your backups encrypted, especially at rest, so that if someone does access it, they can't read it. So this is a big deal because if you're storing a lot of company information or a lot of people information, such as PII data in clear text, well, then that means anyone can log into that server and read it. So you want to make sure that that's encrypted. Snapshots are also a really good, excuse me, snapshots are also a really great way to have effective backups because then you have a backup of a certain point in time. So a snapshot is like taking a picture. When you take a picture, that time, that location, and is locked in. So you can have a backup of one specific point in time, which can be useful. Let's say if I were to have a snapshot of all of my data yesterday, well, then if I get ransomware today, I can just say, that's okay. Since I can't access any of my servers here, let me just back up my snapshot. It was just a point in time yesterday or what have you. Recovery is just um, Recovery is just decide is how quickly you bring these back online. There are two measurements that are typically used, RTO and RPO. RTO stands for recovery time objective, and RPO stands for recovery point objective. Now, these are two terms to at least understand. To put it in very simple terms, it's just measuring how much time are we allowed to be unavailable before it becomes catastrophic, or how much data are we allowed to lose before it becomes catastrophic. It's typically measured in hours, okay? Hours and days. So an example is, all right, recovery time objective. If we are a bank, like Abdul said, well then, are we able to go without our systems for 1 hour? How about 2 hours? What about 4 hours? What about one day? What about 3 days? As you can imagine, if people can't access their money in, let's say, like one day, that's going to be a problem. So that's where we would categorize it as critical or disastrous. Replication, that's just having copies of certain amount of data and having those copies made in real time. This is a redundancy step. And then journaling is just keeping a log of all of the changes of the last backups. And if there is any failures, it's just a way to monitor that. So if we're talking about effective testing and backups and strategies, these are all ways you can test. These are all the ways that you can back it up. Now, we will talk a bit more about offsite backups here in a bit. All right. So offsite backups, the reason why they're showing you this is essentially when you store your data, and we'll keep it to data at this point, if you're storing your data in a place that is physically different from your office or physically different from your place of operation, okay? Now, this is important because it ensures that your data isn't lost in the case of a major incident, such as a flood or a theft, right? So if there was a flood at your business and all of your data was kept at your business, that's a single point of failure. The entire concept of resiliency is to make sure that you can make it available again down the line. So how does it work? Well, there are four different ways that offsite backups can work. One of them is geographically separated. That's why they show you a storage unit here. So you can store all of your data in one storage unit or something that is like geographically away from where you currently are. Remember those four buildings I told you about when it comes to Intuit? That can also be geographical. If building one, let's say, has some data servers, a reminder, a data server is where you host all people's contacts or just data in general, right? Building two can have the same copy of the data that's in building one. That's an exact example of geographical separation, where you store that backup in a different location. Now, the proximity can differ. Sometimes it can be right next to each other. Sometimes it can be miles away. Sometimes it can be in a completely different other region. But the idea here is to have a backup in a location that isn't affected by an actual incident. Backup frequency, you do have to keep that in mind because if you have an offsite location, keep in mind that these places, you typically have to go in and drop off the hardware. This would be like the air-gapped one. So you need to have someone be able to physically go in and store any of those devices. Now, that being said, though, it's you don't have to have it in a place that doesn't have internet. It's a good idea to, but you can have it connected offsite, but it's connected to the internet where it automatically updates as you make those backups. Now, as I mentioned, when you are creating those backups, if you're sending those backups to another building, you do have to make sure to send it securely, which means that you have to encrypt those connections, which means you have to do it through a VPN, and you need to make sure that it doesn't get accessed in transit. And then the last one is accessibility and recovery. So the entire goal of these offsite backups and resilience in general is to get everything up and running as quickly as possible. So typically you would want to have a easy way to get to these backups and an easy way to retrieve them and bring them back online, which is why cloud services are so popular. We'll talk about that later on. Now, why are they important? Well, for one, it's really important because disaster recovery, it's can it can bring that back up very quickly. Has there ever been an incident where the hacker attacked the primary network plus the backups? Yes, Peter, that's a great question. I have seen that in the past where if they were able to get access to the internal network and if they get access to the network architecture, well, then they'll know where those backups are. Now, typically that information should be kept pretty securely to only those who need to know. But if that does happen, well, then they have been able to get into the primary network as well as the backups. Is it necessary to back up the backup just in case? Xavier, yes. This is the whole point of redundancy. It's to back up the backup of the backup. That's why I have mine in 3 different backups, right? Because if you back up the backup, well then, sure, maybe the hacker got access to the first backup. Well then, they may not know that there's a second backup or even a third. This is one of the best ways that you can combat ransomware is to have backups. Great question, Xavier. I think it's fully necessary to back up the backup. Data resilience. So that's making sure that you have copy of critical data. So that just means creating a backup of a backup, right? Resilience and regulations. So this is centered around making sure that you're meeting the requirements of any compliance standards that you're trying to talk about. So for this one, right, we have SOX compliance, right? So the SOX compliance stands for the Sarbanes-Oxley Act, and it's essentially because some organizations were found to be financially dubious and unethical. So this is one of the ways that they control that. And in those compliance standards, they have certain controls that that require you to have backups. And those controls vary based on different based on different compliance standards. And then here's some real life examples. I mentioned AWS, Azure, and Google Cloud before. They all have backup systems. They all have backup systems in different locations. And then there's offsite data centers. So that means that there are data centers that you can access. Typically, they are like they are data centers that look like this. So they're the ones with all the wires, with all different servers. Now, a data center can be a business in and of itself where you host all the backups for a certain company so they don't have to run through all of the logistics of that. It's typically accessible via the internet. Now, one of the important things that you have to remember is when you are getting your backups back, you need to make sure you're doing it through a secure location, and then you need to prevent access. That's correct. The other one is regular testing and validation. So you never want to be caught in a situation where you need to get your backup, but your backup function is not working. This is why regular testing and validation says, hey, is it working? Great, it's working. That's fantastic. Okay, so this is why monitoring helps, is to make sure that all the systems you're using for backups are important and needed. when you have a backup? Should you override the previous one or keep multiple backups organized by date? And what if you try only to discover you're infected with a worm after making a backup? Won't that mean you backed up the infection itself and can't form a clean restore? What's the strategy in that case? Very good question, Andre. Very good question. So, to answer this, one of the reasons why I say disaster recovery is one of the most important and one of the most technical roles in GRC is primarily because of that. You need to have measures in place to make sure that your backups are complete and accurate. So this is why completeness and accuracy are important traits for someone who's going to be doing disaster recovery. Because for one, I do not think that you should override the most recent backup. I think you should keep certain backups for at least a year. Now, as you can see, if we're talking a year, that's a lot of backups, that's a lot of space, that's a lot of money. This is why it comes to risk appetite, right? So that's one of the reasons why you do need to back them up and you shouldn't erase the most previous one until it becomes apparent that you may not need it, right? It depends. Each business is going to be different. And then if you discover that one of your backups is infected, this is why testing is important. This is why regularly validating it and checking its health and monitoring it is very helpful, right? Um, yeah. I think that answers your question. So the strategy for that is just to do a lot of verifications, make sure you have controls in place where you can check the health of it. Typically, each backup is going to have like kind of like a health bar, so you can see the health of a specific backup, and you'll get a suspicion or a notification if like an intrusion detection system, where if they say, "Hey, we detected a worm with this specific signature, take a look," that kind of stuff. Great question. Quiz time. Quiz thread. So, A, B, C, or D. In what scenario are offshore backups particularly beneficial for data recovery? A, B, C, or D. All right. Everyone is saying D. That is correct. So if you want something offsite, well then it's because you need geographical redundancy for disaster recovery. Very great. Thank you to all of you who answered on the thread. All right. So then now let's talk a little bit more about encryption. I mentioned how encryption is one of the best ways to stay secure online, right? Well, as a reminder, encryption is a concept of kind of scrambling the data so that it becomes unreadable unless you have the right key. Keep that in mind. A key is one of the easiest ways a key is one of the best ways to encrypt your data or to make sure that it becomes unreadable to everyone else. Why it's important is because you want to make sure that whether data is at rest, meaning that no one's using it, whether data is in use, meaning that someone is actively creating the data or working with the data. Think of it as if an employee were creating a spreadsheet. That's an example of data in use. Or data is in transit. So it's like you're sending an email to someone with an attachment. All three of those have to have an encryption level to make sure that it still functions. Okay. Now, there are advanced encryption methodologies, advanced ways to make sure that it is as undecipherable as possible. So one of the first ones is homomorphic encryption. So done, this is essentially when you have you have encrypted data, right? And you don't need to decrypt it first, okay? So it's a very advanced encryption process where they are encrypted, and then when they get decrypted, they get matched accordingly, okay? So the entire idea is homomorphic, right? It's done in cloud platforms and specifically very privacy driven, but they match the result according to like the data that it stores. Okay. Then there's quantum cryptography. So quantum cryptography uses what we call quantum computers or very, very complex computers that can create very specific algorithms or very specific um, encryption standards that can take a while to be decrypted. So one of the things that you'll run to is called a QKD, which stands for quantum key distribution. Essentially, um, it makes sure that there isn't any eavesdropping, someone's not listening or altering any of the data that's being transmitted. Post-quantum cryptography, it's essentially an algorithm because when I say encryption, right, you are using an algorithm to encrypt and decrypt the information, right? So in this case, it's an algorithm that is meant to combat an attack using quantum computers. And then there's something called an ABE. So an ABE is essentially, it stands for attribute-based encryption. So this is a public key, meaning where the secret key of the user and what we call a ciphertext are dependent on an attribute. So let's say it's your role, maybe what country you are, maybe like a certain at email address, so like at google.com, at intuit.com. Those are attributes that can be used as an encryption key and encryption pattern to unlock and lock information. So these are all different types of encryption. Now, will you need to dive this deep when it comes to encryption? That's on you, depending on what role you do. So, as you can imagine, each of these has a certain key that allows you to encrypt and decrypt that information, right? So, you might be asking, okay, well, how are those keys stored? Where are those keys stored? And how specifically do we share them? How specifically do we generate them? Just like how we have a web server completely dedicated to a website, a data server completely dedicated to storing and hosting data securely, you can have what we call a key server as well. So the quote unquote key server, to put it quite simply, to put it quite simply, is the key server would be where you would store all of the information of the keys and be able to share it accordingly. So there's a concept of centralized and decentralized key management. Essentially, centralized key management is where you take all of the keys and you put it into one single system so that it's easy to audit, easy to essentially monitor, keep track of. Now, you could decentralize it, meaning that it's not all in one system. It can go into multiple systems. So multiple systems can mean it goes to different countries, different servers, different organizations in general, right? The point of this is if it's centralized, it becomes one single point of failure versus decentralized, meaning that it can be spread out. Now, with every key, as you can imagine, they have to have an expiration date. You can't have the same key for 5 years. At some point, that key may become exposed. So you need to do what we call a key rotation. That means regularly changing the keys to reduce the risk of compromise. Okay? When you when you rotate them, well, then that means that the key changes. Now, there are systems where the key will automatically rotate and there will be no action needed from you as a user because that key unlocking and locking happens on the back end, meaning you won't have to worry about that too much. Okay? And then there is the concept of hardware security models, HSMs. So an HSM is just a physical device that stores and manages any of the encryption keys. Ben Long says, is ABE symmetric encryption? So the answer is no, it's not asymmetric encryption. It's actually asymmetric. So there are two separate keys for that. Centralized is more secure than decentralized key management. So it depends how you view it, because centralized does mean that it's easier to manage and easier to monitor and work through. However, I wouldn't call it more secure because decentralized means that you don't have that single point of failure. But it depends who you talk to. This is where the concept of convenience versus uh, compromise comes into place. Okay. Now, I'm telling you all this from my perspective. There may be some other cybersecurity professionals and even some TAs who might disagree with me, but that's for those organizations to discern. Now, I already talked about these three, so I won't dig in too much into them. There's data at rest. So that means data that you're not using that's stored in a specific location. Then there's data in transit, which means data that's being sent over the internet. And then data in use. So when it's someone's actually working on it. Now, each of these have their own encryption level. As you can imagine, data in transit needs to be done through TLS and SSL as well as PGP and GPG. You can look these up on your own. So, what are some things that you need to keep in mind? Well, like I mentioned before, there's a concept of performance versus security. So, you want to make sure that performance is still functioning as expected. And then you also want to make sure that there's adequate security. So, keep in mind, this is about risk appetite. Then you need to look at the requirements for all the different standards that you need to adhere to. If you remember last class, I said it's important for you as a business to know where you stand in the security industry so that you can go ahead and put the right controls in place. And then there's interoperability. So that means trying to understand if you need to have everything in one system, multiple systems, if you need to have different devices, different applications, different third parties, or if you need to just have it all in one. Secondarily to that, you need to make sure that any of the other systems that you use are multifunctional, meaning can they work with each other? Do they have an open API that you can connect to that allow you to do any X actions. All right, let's do one more. So I think we had already talked a lot about these. So what are the things you need to keep in mind when it comes to encryption? Well, one of the first things we want to keep in consideration is scalability. Now, your organization, a good organization will grow, right? So because the organization will grow, you need to build with scalability in mind. You need to make sure that if you're going to be doing encryption, well, then that encryption might take up more space, and that means that might be more money. If you're doing a lot of heavy encryption, well, then that might take a load on your Wi-Fi and your internal internet. So your performance might go down. The performance of your internet might go down. So you need to keep that in mind. This is why it's important to have someone be able to speak this language to higher ups because they're making the decisions. Access control integration. You remember when I mentioned how Azure is typically used for IAM, which is for identity and access management? Well, then you need to make sure that you have an integration that works on multiple levels with different capabilities with different softwares. So I mentioned RBAC, that stands for role-based access control. Then you need to have something that has ABAC, attribute-based access control, and MFA, multi-factor authentication. All of these need to be present in order to make sure that all of the systems can work together accordingly. Automated encryption workflows, this just means that you're automate, for example, if we're talking about keys. Like I mentioned, the keys have to expire, they have to be rotated, and they have to be sent and used, right? If you can automate this process so that no one has to act, a human doesn't actually have to click anything, that saves so much time, money, and energy and resources, right? Not to mention, it reduces the chances of human error. So automating that workflow of the keys is essential. Auditing and compliance reporting, this is pretty straightforward. If you have encryption strategies in place, you need to make sure to audit them. Like an example is you need to make sure that if you're automating all of your key management, you need to audit it and make sure that it's working properly. Then you need to prepare the document and evidence to give to any compliance or any of the auditors. Data recovery and backups. So because encryption takes up a lot of data, you need to have a backup of all the encryption functions. Okay. So making sure that you have a backup of all the encryption keys in case so you don't have a single point of failure. That's important. And then the last two is making sure to educate your stakeholders to let them know, hey, this is how the keys work. If you ever have any issues, reach out to us here. And finally, evaluate the encryption solution. So this just means looking at how your encryption strategy is working in your system, finding out what works, finding out what doesn't work, and reevaluating if you have to pivot or make any changes, right? That's all that means. Now, if it works, great. If it could be improved, even better. Do we have to replace the whole thing? We'll see. That's the entire point of the evaluation, is to find ways to make it more efficient and at times um, potentially even cheaper because maybe there's a new solution comes out that does that. All right, let's go ahead and take a pause here. We'll take a quick 15-minute break. So, Gracia, if you could go ahead and put 90 ducks on there. I'm going to put the duck thread here. So, all right. All right, let me go ahead and share my screen. As I'm doing that, we had a very interesting request come in from Alex. So Alex was saying, I'm interested in a real and practical incident response plan. Do you have a sample to share? So here's the thing. As you can imagine, an incident response plan stays very protected. The reason why is because if your incident response plan is public or if a threat actor gets access to it, well, then they know all the steps you're going to take in order to bring your system back up, meaning they can sabotage it. So typically, those plans are not easily shareable. However, there is another resource that I can provide you. So let me see where it is. I think, okay. So it would be this one. So as you can imagine, you guys all remember CISA, right? So the Security Infrastructure Security, Cybersecurity Infrastructure Security Agency, CISA. So they have this, which has the basics of an incident response plan, what it should contain. They also give you like specific recommendations of step to do. If you dig, and I'll put this here in the chat for you all. If you all dive a little deeper into this, they have a NIST guide, which, as a reminder, I mentioned to everyone, NIST is one of the frameworks that you should be familiar with because it is one of the ones that is, there we go. That was probably really messing with some of you, so I apologize there. Um, it is one of the key publications and key frameworks you should be aware of. All right. Now, they do have this newer version here. So that I like this because it has actually the handling guide. And here they have an actual very in-depth document. Now, if any of you would like some night reading to help you fall asleep, this might be one of the documents for you. It does go very heavily in depth into what you should do. Keep in mind that incident handling guide is synonymous with incident response plan, right? Because it's just saying, hey, here's a playbook on all the things you should do in order to handle an incident. Okay. So this goes pretty in depth. If you are interested in reading this, or if you're interested in downloading it and having ChatGPT summarize it for you, those are all options. Alex, hopefully that's helpful to you. All right, let's carry on here. Now, let's talk a little bit about data duplication. So, in very simple terms, data duplication just means um, data replication just means copying data. That's all it means. It just means copying data from one place to another. The concept here is you want to copy the data in real time. What that means is if I create a file on my computer that just says test file, well, then that file should be created in all of the other copies of where we have our backups, right? Now, if I were to go ahead and say test file one, well, then that new version should also be copied in all of those other locations where data is backed up. The reason why we do this is A, we want to make sure there's redundancy so that if I make a file, then I can always reach it, make sure that it's available. And then a term that you will now learn is synchronized. So data synchronization is just making sure to synchronize data between all backups. As you can imagine, let's say we're a cybersecurity company. We have a really strong resilience program where we back up all of our information in 4 different places. So that means every time I create that test file should be synchronized to all 4 backup locations. If I make a change and call it test file 1, that new file should be synchronized to all 4 locations. So the synchronization process is essentially making sure that the data is able to be recovered and being put in those backups in real time. Okay, that's the entire process of synchronization. Now, there are other methods of replication. So you can do a snapshot like we talked about before. So a snapshot would be if I create a file that says test file, but then I don't make any changes to it for 2 days. Well, then that snapshot backup will just be just that point in time. Okay. So there's also transactional, which means you only back up the things that are required, and then log-based. So if there's a specific need or if there's a specific need for that log, what have you, then multiple copies. All this means is that of those 4 locations, one of them is in the building next to us, one of them is on cloud, one of them is in another country, and then one of them is offsite, right? So you need to have multiple copies on all those locations. As you can imagine, if you have something that's offsite, well, then you can't, and it's not connected to the internet, you can't back it up in real time. It has to be backed up like on a monthly or quarterly basis. Okay. And then data consistency. So this is again about the completeness and accuracy of the data. If you have an automated system that synchronizes your data properly, well, then it should remain consistent. But like we said before, this is something that you have to test. Now, as you can imagine, this is incredibly important, right? Well, for one, we already talked about high availability because we want to make sure that information is available to us at all times. That's why data replication or copying data is really important. Also, it improves the performance through load balancing. It removes any congestion. Now, depending on how you do it, that can be changed. Sometimes, keep in mind, sometimes some companies will create an entire network that is only dedicated to backups and disaster recovery, meaning that no one else has access to that network except anything that does backup. It is to reduce congestion on the internet internally. Is there some differentiation between data replication and redundancy? Slightly. They're pretty much the same thing. The term redundancy is the term redundancy, I would call like the blanket statement or the top title statement. And then data replication falls under that. That's a very good question. If you were to like describe what did we learn today? You say, hey, we learned about resilience and redundancy. Resilience is the process of making sure we're able to bounce back quickly if there is an incident. And then data replication is a part of resilience. Data replication is a part of redundancy because redundancy is having backups on backups on backups. Data replication is a part of having those backups. Great question, Saida. Great question. And then disaster recovery, it's a lot easier to recover data when you have multiple copies of it. Gracia, can you give me a thumbs up if you hear me okay? All right, someone says there for screen. Okay, I'm good. All right. Janubi, you can go ahead and you might want to check on your side there. Okay, awesome. Now, database replication and file replication, to put it quite simply, database replication is where you're taking a total, complete and total database and you replicate it into another location. You want to synchronize it accordingly. Whereas file replication is just duplicating and copying a bunch of files. That's all it is. So think of database replication as an entire server or entire database. file as individual files. Okay. Now, two things you have to keep in mind. Data replication is important and synchronization is important because you want to make sure that there's no lag. You want to make sure you're delivering as soon and as fast as possible. So you want to make sure that there's no lag between it. And then you want to make sure that there's enough bandwidth on your network in order to handle it. This is why I said some organizations have a process there where it is completely and totally dedicated to one service, which would be data replication and backups. Now, some of you had asked last class about RAID 0 through 10. Well, this is the class where we actually talk through it. As a reminder, RAID is a backup system. The actual term for RAID is redundant array of independent disks. It's a fancy way of saying backup hard drive. That's really all it is. A fancy way of saying backup hard drive, all right? So what it does is it combines multiple different hard drives into one single logical system, okay? That's all it does is combine multiple hard drives into one single logical system. And they're categorized into different categories, okay? So the first one is RAID 0. That's also something called stripping, okay? So all it does is that data is split across a bunch of different disks, okay? But there's no redundancy. It just put in a bunch of different disks, all right? So this is bad because there's no redundancy and it's one single point of failure. Meaning, all right, we just put data in one location, done. That's RAID 0, okay? Now, the good thing is it's fast. So sure, you may have a single point of failure, but it's very quick. So that's RAID 0. That's called stripping. And then there is RAID 1, which is called stripping with parity. So stripping with parity, sorry, RAID 1 is mirroring. My apologies. RAID 1 is mirroring. And that just means that it creates an exact copy on two or more disks. That's all it means. It creates an exact copy on two or more disks. Now, is this as fast as RAID 0? No, it's not. It writes a little slower. However, it does provide full redundancy. Here, all right, it's just one backup. Here, there's the same. So there are two drives, drive 1, drive 2. So both these drives are completely identical. They mirror each other. Okay, so this does have redundancy. If one of them fails, you can go to the other one. And then there's RAID 5. This is the one called stripping with parity. So this just means that you have data. Well, first of all, let me define this. Parity in very simple terms is it's doing an error check. All right. So there's error check information to make sure that nothing has been changed. Okay. So it is stripping the data as well as the parity, doing an error check, and putting it across not just two, but multiple different disks. Okay. So the idea here is that it does have further redundancy because it's not just one backup, it's multiple. And then the other piece is that there is a performance issue because you're doing an integrity check. You're making sure that there are no errors. So when you do that, it can cause some performance issues on your device. So this is an example of what RAID 5 would look like. So it would be, okay, there's drive 1, 2, 3, 4, and then each one has a block. One of those blocks is dedicated to parity. So that would be one of the reasons why it would take up a bit more space. Then there's RAID 6. So all this means is there's an extra layer of parity, right? Meaning there's doing some extra checking. And the good thing is it's a better fault tolerance because it has multiple different drives that it can fall back on. But the problem is it does take a lot of overhead and a lot of storage. And then there's RAID 10. RAID 10, in very simple terms, is just putting RAID 1 and RAID 0 together. So as you remember, RAID 0 is just copying everything on one, and then RAID 1 is mirroring everything. So that's all it is RAID 10. So RAID 10 is good because it has high redundancy and high performance. Now, depending on your organization, obviously, because it's high performance and high redundancy, this would seem like the best bet, correct? However, you have to keep in mind some organizations, they may not have the money for RAID 1 and 0. They may not have the money for RAID 6. So if you're, let's say, like a startup, maybe you might start with a RAID 0 with the idea to scale. If you're a government contractor operating on government information and proprietary information, well, then you would be a RAID 10 because, or sorry, you would probably be a RAID 6 because you want to have a bunch of redundancy. You want to have a bunch of error checks or parity because they have the money for that. Okay, quiz time. Question, let me see, thread. Did see Kiran, I see your question there. Um, There are raids 2, 3, and 4, but the reason why they aren't listed here is because they're kind of pretty obsolete and not as used. So they're not as up to date, I would say. The ones that you see more often is raid 0, 1, 5, 6, and 10. That's why they're not there. But they do offer different functionalities. They're not meant, you don't need to know them for this particular class, but you can look them up. So just keep that in mind. All right, quiz thread, A, B, C, or D. What is the primary objective of cyber resilience? A, B, C, or D? All right, the answers we're getting. Everyone is saying C, continuous operations despite disruptions. That is correct. Well done, everyone. So if anyone asks you, oh, what'd you learn today? We learned about cybersecurity resilience. It's meant to make sure that the operations of a business continue to function, even if there is an incident, and how quickly we can bounce back. Great job, everyone. All right, so what are the threats that we need to protect against nowadays? What are the threats we need to protect against nowadays? Well, to put it quite simply, you can't protect your organization unless you know what your organization does, what data you have, and what kind of data would be the most impactful if it were stolen, right? So you need to understand your industry and your data and your company first. After that, then you need to look at the industry threats that exist out there. Well, like I mentioned before, one of the key threats that still exist today is ransomware and social engineering. So as a reminder, ransomware parades itself as like a legitimate software. And then if you download it, it encrypts your data, and then you have to pay to get access to your data again. Okay. So typically, this is done through social engineering, such as phishing emails. Maybe it's a device that you plug a USB into. There are multiple ways malware can be installed, but it is still one of the easiest ways to exploit a system because then it freezes your system and then it doesn't allow you to use it any longer. Now, one of the reasons why backups are so important is because if you have a backup, well, then you won't have to worry about ransomware because you just go back to your most recent backup. That could be a day ago, a week ago, what have you. Then you'll have access to your system again. Easiest way to combat it. And then there is AI-powered attacks. Now, as you can imagine with ChatGPT, if we have access to ChatGPT and ChatGPT has guardrails, there are AIs out there that are starting to be created that don't have guardrails. So you can do a bunch of different automated attacks. So for example, there's something called ransomware as a service. So you can use AI to build a custom ransomware that you want to send to a certain number of people. So now you can use AI to do that. You can use AI to do phishing attacks or DDoS attack. You can essentially use AI to mimic writing. A very common one that's happening right now is using deepfakes and AI to copy someone's likeness and copy their voice, writing style, any sort of mimicking in order to do a social engineering attack. So that is still a common one. We've talked about supply chain attacks before, where if there is a system, company, third party that is very critical to your organization, if you cripple that, well, then it can essentially disrupt your entire industry. So that's what the supply chain attack is. IoT devices, as a reminder, that means the Internet of Things. This means a smart device or a smart application. Speaking of which, how many people have watched The Accountant 2? So in that thread, let me know how many people have watched The Accountant 2. Now, keep in mind it is a rate. I don't know the rating of the movie, but it is pretty action heavy. But if I were you, I would suggest that you watch it primarily because there is a cybersecurity scene in it. Okay. The cybersecurity scene does actually look at IoT vulnerabilities. It shows like a dramatized version of hacking that. Okay. Looks like most of you have. If you haven't yet, it is a great way to check it out. I guarantee you that nowadays, the more movies you see, you're going to see when it comes to like theft movies or crime movies, there's going to be an element of cybersecurity because it can no longer be ignored. Typically, they just say, oh, you're a good hacker, just hack this thing, right? And they say it that simply, but there's a lot more that goes into it. So I think that this is one of the ones that has been a really good example of that. Dun, 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 dun. Yes, Emmanuel, that is correct. It's when the kids we're hacking it. So that's the thing, Ben, about the AI ransomware. Um, It's uncharted territory. Like, yes, the governments and a lot of companies are trying to regulate it and are trying to put some regulations in place, but it's very slow moving. The reason why is because we don't we don't fully understand what are the capabilities yet and how we should interact with it yet. So there are a lot of things that are trying to be worked on, but I can tell you this right now, some of the governments are seeing AI as like a money-making solution. So there might not be that stringent of regulations. All right, let's carry on. So there are some cloud security challenges. Keep in mind when you are using a third party or cloud, well, then you have to essentially move data. You have to essentially address all the challenges with giving it to a third party, making sure that um, they're as secure as possible. And then there's quantum computing threats. So as I mentioned before, quantum computers are just super smart computers that are able to decrypt information easily. Now, the reason why I bring this up is because with algorithms, you can break an encryption if you have enough time. I think, hacking chart. So I believe that there is an image out there. Okay, yeah, this is it. So this is old. This is back in 2023, but this is an example of cracking a password, right? Typically, most passwords should be encrypted. So if your password is only 5 characters long, well, then typically it can be cracked instantly if it's just numbers, if it's just lowercase, like 1, 2, 3, 4, 5, easily crackable, right? That kind of stuff. And then um, if you have even numbers, symbols, whatnot, instantly crackable. Now, if we go to the extreme and say your password is 18 characters long, with a normal computer or normal software, it can take 6 days to go through all the possibilities to do that. Now, look how exponentially it grows if you don't just do numbers. If you do just lowercase or even better, lowercase with a number and a symbol, it can take 26 trillion years. Why am I showing you this? Because a quantum computer can slash these numbers, I don't want to say in half, but a pretty good amount. They can compute and do all these computations so much faster. So that's why quantum computing threats, a way to decrypt the information, is one of the threats that exists out there. All right, let's carry on here. So, for the sake of time, I'm going to let you all kind of read this because I'm trying to go a little slower, but we are slightly behind. So I'm going to just skip the strategies for mitigating emerging threats. It's your homework to just go ahead and review this. You can ask the TAs about this later on, but I think it's pretty self-explanatory. So, Ben, you were asking about AI before, right? And you're saying, hey, well, how can we combat it? Well, just as a reminder, because I know there are different levels of technical knowledge here. If you hear people referencing AI or machine learning, AI stands for artificial intelligence. In essence, it's using machines to essentially do a lot of the work that humans do, except a lot faster with ideally less human error. Okay. When it comes to AI and cybersecurity, we typically use it to detect when there's an intrusion, to analyze large amounts of data, right? Because as you can imagine, it'd be hard for a human to do all that. So having AI do that saves us a lot of time and money. And then it's also used to respond to any cybersecurity threats, right? Now, when we're using AI, of course, it's going to help us with all the automated things and save us time and money. However, there are a lot of challenges, one of them being an ethical challenge. There is a reason why there are so many post-apocalyptic movies saying that AI has found out that humans are a detriment to ourselves because we're fallible. Therefore, we need to be controlled, contained, or exterminated, right? That is a very real thing. That's been something that has been referenced since the early 90s when you watch The Matrix. So AI in cybersecurity is being explored, but there are some areas where it can help us. One of the first ways that it can help is threat detection. Like I said before, there is a huge amount of data that we need to go through in order to see if there's an actual threat. So if we train AI, if we give it all the right information and if we show it all the past incidences, the signatures, it'll learn based off that large volume what would be an actual threat. It'll be able to decipher if there is a threat or not based off the information we provided. So that's a good way that it can detect it. Additionally, because we train it on how to detect it, then it can learn how to respond to the actual incident. So when we're talking about detection, right, it would be the intrusion detection system, IDS. When we're talking about taking an actual response, an active response to an incident, that's intrusion prevention. This is the active amount of stopping the actual incident itself. That means we can typically automatically turn off that threat. So what's being done a lot right now with AI is if they detect a um, a positive threat, meaning that it's an actual threat, well, then what the system will do is it'll automatically drop that IP address or block it, meaning that it can't affect it. Or what a lot of systems do is they will shut down that specific account or shut down that specific segment. As a reminder, segmentation is being used to prevent the spread of an incident. So a lot of AIs right now just shut it down or they isolate it. That's one of the easiest ways to do it because then a human can come in and decide what to do. Keep in mind with AI, we don't want to give AI too much control. We still want humans to be able to make the final decisions. Predictive analysis, this just means that AI can be dynamic, meaning that it can predict any potential or future threats. A very simple example is if there's a time frame when we get hacked more often. Typically a big hack if we have a huge marketing campaign that says we have a new product. That's when you'll see some hackers try and like get in our back system so they can infect that new product to infect new users. Or maybe if there's a new CEO who gets hired, well, then they see that transition period as a potential time frame where they can be hacked. And if we use AI, we can go ahead and predict when this would happen. Enhancing authentication. So this just means that we can use things such as biometrics to improve the accuracy of facial recognition, fingerprinting, that kind of stuff. And then it can also analyze user behavior. So because it's doing predictive analysis and looking at all the logs, it can predict if the user is going rogue. And then security automation. So this is just making sure that it's able to automate any complex security things that we need to do. Now, what are some challenges? So let me dwindle this down to the three ones that I think are I'll say, yeah, the three ones that I think are the most important. For one, some people are growing nowadays where they don't want AI to have their data. So there is a lot of regulation right now that says that AI needs to comply with data privacy laws, meaning that we can tell AI, what information do you have of me? We have to disclose if we're using AI or any third parties. Okay. The other thing is false positives. Now, AI, they can they're getting really smart. That's a true fact, but they're still not completely correct. Even if you use ChatGPT today, they highly suggest that you don't take everything they say as fact. There are times where they will be incorrect, so you do need to be aware of that and be able to sift through it. And the last one is bias. Like I mentioned before, if we give AI full control, it's pretty much guaranteed that they are going to want to take actions to protect us humans, which may be to our detriment, right? So AIs are biases. They're biased because they're trained on bad data. Remember, garbage in, garbage out. So if they're trained on poor data, they might be biased and more judgmental towards poor actions. Thank you, Zainab. Yep. So the ones that I guarantee that right now, all the cybersecurity companies are trying to make things more AI driven, more AI focused because CEOs are trying to sell that we're using AI to be more secure. So if you're using any cybersecurity function right now, they are going to have some element of AI within it. I know for sure that CrowdStrike definitely does. And, oh, Zainab mentioned CrowdStrike and Splunk as well. Cisco has a bunch of new AI tools. Palo Alto is developing some. Every single cybersecurity company has some. Would large companies use AI more in cybersecurity, eliminating the human factor in cybersecurity? Peter, you're asking the right questions. What I read it as, are we humans still going to be needed in cybersecurity because AI is coming into the fold? Yes, cybersecurity professionals are always going to be needed. This is why I say that the soft skills as a cybersecurity professional are important and are needed. Because yes, larger companies are going to use AI in order to, like I mentioned before, log data, do detection, do a lot of the work to save human um, time and effort. However, a human has to be the one to have the final say. They need to make the final decision. They need to make the final go ahead. They need to validate that yes, it was an incident or no, it wasn't. The human aspect is always going to be needed in cybersecurity. They're going to try to push it so that AI makes the decisions, but that's a very dangerous road for technology to go on. Humans are still always going to be needed. Great question, Peter. Okay, I think I think for the sake of time, I'm actually going to go ahead and skip pets. You, I wouldn't, I would say that it's not like completely not important, but it is something that you all need to become you all don't need like a direct familiarity with, but it is good to know. I won't skip blockchain though. So, blockchain, in very simple terms, is a decentralized ledger. So, a decentralized ledger is just like a digital ledger that records transactions and that's transparent and secure. When you think crypto, this is where your mind should go to. Okay. Now, why does blockchain exist? Blockchain exists because it is a very transparent and tamper-proof record of any transactions that are done. It's meant to foster accountability and transparency. That's the main function of blockchain, if you were ever interested. Blockchain is just a ledger for transparency and auditability and accessibility, right? In cybersecurity, um, how is it essentially used? Well, it's used for secure data storage, so you could store that data through blockchain. It is used through IAM because you can use blockchain to help do identity verification as well as store some smart contacts and whatnot. Like I mentioned before, it is meant for secure transactions, so it does have a high level of integrity and security. And I already mentioned it has smart contracts. So a smart contract, in essence, is just an agreement that is written in code. All right. So when you run the blockchain, you make it secure and tamper-proof, which is why blockchain is a huge deal right now. Like the blockchain cryptocurrency company. Yes, Sylvester. Um, Actually, I think this is important. I see Brian just posted um a a link here. Da, da, da. Yeah, these all track. These all track. Yep. Security guards, yes and no. You're still gonna need physical security guards in order to make human decisions. Yes, legal assistance that will be replaced. Yeah. I think the biggest thing to keep in mind here is that it will replace jobs that are repetitive and don't take up a lot of emotional intelligence to operate. All right, I think we're good here. Let's carry on. Ethical considerations when handling data. Well, remember we talked about ethics before. I don't think I need to hammer that home. When it comes to ethics, right? Specifically data. Just because you're collecting and analyzing data doesn't mean you should be collecting and analyzing all data. Okay. So that means that if you're handling data, if people give you their email or their information, it's like someone is telling you a secret that only you should know. So it's up to you to handle that secret because that's the data that should be remaining secret, to handle it with care, trust, and security, right? Now remember, here's a question again. Answer this question. What is our number one job in cyber security? Please put it in the thread. What is our number one job in cybersecurity? My hope is that I said it enough times where it sticks. This is in relation to the prevent harm. The answer is to protect human life. Very good job, everyone. That is completely and fully accurate. You are in the industry of protecting human life. That also means protecting data. There are ethical implications of handling data, which means that you need to keep in mind how you're using it. There's a reason, typically when you work in an organization, they'll have a document that says, this is how you should process and use sensitive information. Now, why is that important? Well, because for one, you need to adhere to all the right privacy standards. One of them is informed consent. Informed consent means that individuals must know when data is being collected, who it's being shared to, and who has access to it. They need to be able to freely consent to having that being allowed or to opt out of it. There was a time, I think it was 2, 3 years ago, where everyone was getting what we call transactional emails. These are emails that you can't opt out of. They're giving you information that you have to know. But they were saying, we've updated our privacy policy, right? The reason for that is this: informed consent. Informed consent just means that you go to a website, and when you go to that website, well, then they typically have a section that says privacy policy. That privacy policy is their way of informing you that by creating an account, you are agreeing to a privacy policy. That's that simple meaning. Minimizing collection, that just means, like I said before, you should not collect all data. It's again the principle of least privilege. You only collect the data that you need. You only process and transfer and move data that you need. You don't need to process and move all the data. Okay. Then the right to privacy. So this is just making sure you're respecting things like GDPR, CCPA. The people have rights. And then there's data misuse. So like minimization, you should only be collecting data for its intended purposeful use. You should not be collecting data for non-purposeful use. There is, for example, there is no reason why anyone should collect sexual orientation if they're trying to sell, let's say, if they're trying to sell cups or headphones. There's no reason why that needs to be collected. Just the same way where maybe you do not need to collect someone's year of birth. There's no reason for that. Smart marketing companies don't collect their year. They just collect the month and the day so that they can target them with happy birthday ads. Okay. So that's a limitation of the just collecting data that you need. So when you are using data to profile individuals, example, you get a bunch of data and you sell it to advertisers. When you sell it to advertisers, they create a profile of who you are and they target you accordingly. Okay. So businesses have to be transparent with who they're sharing your data with if they're selling it. Okay. Surveillance and monitoring, this just means that you are appropriately there's a balance, right? Because surveillance is a pretty big thing, especially in the United States, where they can say, hey, we need access to all your data information because it's a national security risk, right? So employees and governments typically need to have strong surveillance as well as respect the privacy and anonymity of people. And then the last one, regulatory compliance. This just means be compliant with all the laws and regulations that exist out there. Benefit is if you're already compliant, and if you're already certified, good for you. And then data handling. This just means that you have a document or something in place that says, hey, this is how we are protecting / using your data. That's all ethical framework for handling data is. Okay. All right. So I brought this up in last class. I know that some of you are interested in it because it's a potential career path. So I use the term BCP. BCP stands for Business Continuity Planning. Business Continuity Planning is a part of the overall term called GRC, which stands for Governance, Risk, and Compliance. So GRC tends to have a role where it's focused on governance, risk, and compliance. Business continuity planning is a risk function, meaning that its entire goal is to make sure that we have a plan to continue the business if there were to be an incident, such as a disaster, cybersecurity attack, or if there's any sort of crisis. Now, what does it typically consist of? It consists of risk assessment because this is the process of identifying any risks or vulnerabilities that exist in your business and then helping prioritize them so you know which ones are critical and which ones are not. And then you come up with continuity strategies. So this is where you come up with a plan or a playbook to how to restore your operations, to restore your backups in case of an incident. And then we have a like RTO, RPO again. And then there's resource and asset inventory. So resource and asset inventory is just making sure you have a catalog of all the data, all the systems. You have a list of all the personnel that work in your organization or department so that you can have a head count. An example is when we had an earthquake in Bangkok. Well, then all of the managers had to take a head count of all the employees to make sure that they were safe. Okay, that is a step you need in order to do asset inventory. Keep in mind, as a company, asset is not just data, systems, computers. It's also human resources. You need to know how many human resources you are because they technically are an asset to the company. Then you need to make sure you have redundancy and do testing. This is one that a lot of businesses tend to miss. It's having a communication plan. So that means to know who gets notified, how they get notified, and then what steps to take during the crisis. This is a business continuity plan. This is having a pure write-out on what to do, okay? And then doing testing and conducting trainings. This is just training the employees, specifically the managers, and making sure the managers socialize the BCP to all resources. So why is a BCP important? Well, for one, if everyone knows what to do, who to contact, and the steps to take to get their businesses back online, it minimizes downtime, which in essence minimizes financial loss. What it also does is improves resilience. That means if an incident happens, everyone already knows what to do. It's like if you had a fire in your building and you already know where the stairs are. It's as simple as that. So it enhances your resilience to that situation. And the last one is it does help keep you compliant as well as have a high reputation. A lot of the compliance standards require you to have a BCP, a business continuity plan. Now, obviously, BCPs are important for natural disasters. COVID-19 was a big one. So many organizations had to what we call activate a BCP. So your BCP is dormant. It's not activated or anything until an incident happens. And if an incident happens, you say, okay, we're activating our BCP right now. These are the steps that we need to take immediately. And then you deactivate it when things are back online and functioning. Okay, quiz time. What is the primary objective? Quiz thread. Quiz thread. What is the primary objective of business BCP? Right. A lot of people are saying A. That is correct. It is to ensure the continuity of critical operations. Very good job. What role does BCP play in minimizing downtime during a security incident? For the second question, A, B, C, or D? Okay. A lot of people said A. Well done. That is correct. So BCP is important because it helps prioritize and any critical functions that are required. Now, when you see critical functions, another term for this is critical business activities. Critical business activities. So think of it very rudimentary. That just means what do you need in order to do your job? What do you need in order for your system or your specifically your department to function? Those are the questions we ask during while we're building the BCP. That means, for one, you need a computer, you need internet access at the very basics. Okay? Oh, I see it's different for you, Andre. Yeah, typically when I ask these questions, it's like what you see on my screen. But good observation there. So critical business activity or critical business function is just what do you need in order to work. More often than not, if you're a company, you need a computer, you need internet access, you need access to, let's say, these different tools. Those will all be deemed as critical business activities. All right. Now, we mentioned this before. What is a DRP? A DRP stands for Disaster Recovery Plan. So I am going to Okay, yeah, we have to go through this. So, a disaster recovery plan, in very simple terms, is just a documented and structured approach to how you respond to and recover from an IT disruption. Now, if the BCP were to say, hey, how do we continue our operations? It's about operations and get back up running, right? Disaster recovery is how we respond and recover are IT disruptions. Okay, so typically the BCP and DRP work in conjunction with each other. All right. So, like again, just like how you do the BCP, you do a risk assessment, right? And then you do a BIA called a business impact analysis. You do a risk and you look at all the business impacts if something were to happen. After that, you come up with the recovery objectives. So, this is where RTO and RPO come into play. Our PO is recovery time objective. It just says, how long are we willing to be down for? Recovery point objective is how much data are we willing to lose? And or is how much data are we willing to accept to lose for this? Okay. So those are the two measuring points for RPO or for disaster recovery and BCP. Disaster recovery is where backups live. So you need to have a backup in place in order to bounce back too. That's why it's so important to make sure that you have a really good backup strategy. All right. So why is this important? Why is disaster recovery important? Well, in essence, if you have a solid DRP, a solid disaster recovery plan, it reduces the chaos during the emergency because, for one, you say, oh, we have a good disaster recovery plan. It's already in place. All of our systems are back up and running. And then, in turn, that protects your revenue, it protects your reputation, and it protects your data. So, technically, the way I've seen it, is when we had a really bad incident, the managers and all the teams would say, okay, we're activating the BCP. Here are the things we need to do to get back up and running. Let's move all of our traffic here. Let's move all of our softwares to this location and let's shift everything online to this web server, right? At the same time, disaster recovery says, all right, great. One of our data servers has been corrupted by malware. Let's just fail that over to our other backup system so that everything is back up and running. And then let's kill the current version of the one that's infected, replace it with the backup. And then that would be the disaster recovery. So with that in mind, you're essentially completely bouncing back. We as a consumers should hypothetically never feel it. We should never have a disruption to our systems because we experienced like a really good disaster recovery plan. Now, this is if it were to be a security incident. If it were to be something such as like a hurricane or a flood, if there's physical damage, well, then the disaster recovery plan would obviously take a bit longer to get back up and running. However, we could have safeguards in place. Of course, there's also the concept of regular testing and employee training. All right. So, how do you establish a disaster recovery team? Well, more often than not, you would have a resilience team, and that resilience team is a group of individuals who manage and execute the entire process during a IT crisis. Okay? So, when you do that, you have to find team members that are experts in that field. So in past structures, I've seen there be a GRC team lead that oversees all of governance risk compliance, a crisis team lead, and crisis is someone who manages business continuity as well as disaster recovery. So the crisis would be the team lead. And then you would have a technical expert that would be able to perform and knows all of the different places where there is data to be saved, followed by a designated individual for communication, which in this case is mostly managers. After you have the team, you define who does what role, what the chain of command is, what they have to do when, why, and then you have to list out all the tasks, communication plans, and whatnot. You go through training, you make sure that they're aware of all the different statuses, and then you create a recovery plan. So that recovery plan, it will be in conjunction with the business continuity plan. You do some testing simulation, and then you make sure that you have correct communication and collaboration. When it comes to documentation, however, you have to document from the very beginning, from the start. Is there any role of change management in this? Just curious. Abdul, that is a great question. So it depends on the organization. Each organization is different. More often than not, if you are a big organization, well then your communication liaison would be a project manager or a GRC specialist that would serve as the change manager. Great question. And then continuous improvement. All right, quiz thread. What is the primary role of a disaster recovery plan in cybersecurity? What is the primary role of a disaster recovery plan in cybersecurity? A, B, C, or D? And everyone in the thread answers, they say C. Well done, everyone. It is to ensure the continuity of operations and disaster recovery after an incident. Great job, everyone. Thank you for responding on the thread. Okay, the next topic is incident response. Now, I've talked about incident response before, so we won't spend too much time on these slides. So in essence, if there is an incident, whether it's an actual crisis or an actual breach or security incident, you need to have an incident response plan. This is also called an IRP. Anytime you see IR in cybersecurity, you should immediately think incident response. Okay. So what are the important things to have in an incident response? Okay. This just means, all right, we have an incident. What are the things we need to do? Well, we have to do something. We need to take an action. If we see that there is an actual incident, well, then we need to detect it. We need to raise the red flags. We need to start a communication plan. This is why one of the first steps is identification. After that comes containment. So you need to minimize the impact, meaning you contain the threat wherever it's at, and then you want to reduce downtime. The entire goal of an incident response plan is to reduce the amount of time that the incident is happening. I've gone through some incidences where it's lasted 15 minutes. I've gone through other incidences where it's lasted 3 days. I'm talking 3 days of very little sleep, sleeping in the office, coming in at 3 o'clock in the morning, that kind of stuff. Okay. But the entire goal is to reduce downtime. Then you want to make sure to protect your data and assets. Having an IR plan, make sure that you do contain it or you do protect it, because not only have you taken all the steps to put protective measures in place before the incident, but during the incident, you still keep the data and assets in mind. There are components of communication with incident response plans. Typically, if you're a publicly traded company and you experience a breach, you have 72 hours after the identification or the validation of that breach to share that with your shareholders if you're a public company. So you do have to adhere to proper legal requirements. Sometimes there are some laws that say you need to disclose your breach to law enforcement within 24 hours. So there is a ticking time bomb, which is why sometimes instances can be really stressful. Then it increases your security posture. So this is something everyone needs to memorize, okay? So I highly suggest you memorize this. The stages of incident response. So there are 6. First, you have the preparation stage. This is everything you do before an incident even happens, meaning that you have an incident response policy, you have an incident response team, you have a playbook in place, you have a written out steps that people need to take during an incident and everything. Something to keep in mind during the preparation, if there's an active incident happening, well, then you have to make sure to have a communication plan. What happens is if you're a company that has Slack, well, then if there's an incident, someone who identifies it will open up a Slack channel, add all the very important people, add all the managers just so they're aware, just so they have visibility, and then they start talking about it there. This is typically called a war room. A war room is a room that's created specifically talking about that one subject so that it can be referenced in the future. So when an incident is happening, you have to identify it. So you identify it, you detect it, and then you have to validate. whether it's an actual incident or not. If it is an incident, well, then your next step is to contain it. So this is what I mean by having network segmentation in place, making sure that data is backed up, where you contain it all in one location so it doesn't spread. So the idea is just overall containment. After you contain it, you eradicate it, so you move any of the threats associated with it, followed by recovery. This is where the DRP and the BCP come into play, and then a lesson, and then something that is done very frequently is you do a post-mortem. A post-mortem is also called a lesson learned. Now, keep in mind, a productive lessons learned is not a time to point a finger and say, you did this incorrectly. Instead, it's a time to reflect on what has been doing well and what hasn't been done too well. All right, let me double check here. I think I've talked about the rest of these other slides before, and so I'll let you all do that. For the sake of time, let's go ahead and pivot into the quizzes here, and then we'll do the Kahoot. Okay? So, final quiz thread. Oybeck and Zainab, just as a head note, you might want to go ahead and just quickly review those steps that we went through with them in another course if needed. I think it's pretty self-explanatory, but just making a note of that. All right, first question. A, B, C, or D. What is the primary purpose of utilizing offsite backups in data management? All right, everyone is saying C. Great job. That is correct. So it is to provide redundancy and protection against site-specific disasters. Great job. Question number 2. How do offsite backups differ from onsite backups? How do offsite backups differ from onsite backups? A, B, C, or D? People are saying C. Great job, everyone. That is correct. Question number 3. How do recovery frameworks contribute to cybersecurity? How do recovery frameworks contribute to cybersecurity? A lot of people are saying D. If you picked C, the key element here is it says without any plans. So that would be incorrect, right? Because having a framework does involve planning. So it would be D. Question number 4. Why are comprehensive incident response plans critical in cybersecurity? A, B, C, or D? Everyone's saying A. All right. And the last one, 5. How does disaster recovery plan differ from the BCP? I mentioned this very briefly. A, B, C, or D? Okay. A lot of people are saying C. So yes, disaster recovery is a broader strategy, but technically the business continuity feeds the disaster recovery. Now, that goes a bit more into specifics. I'll talk about that in our first class.